Hello, everyone. Welcome to another Sustainable Buildings Canada webinar. My name is Adam Jones. I have the pleasure of being your host today. Um, Hopefully we have everyone, but if people keep joining through the introduction, that's okay also. Um, Today we are
Hello.
here for a webinar about mass timber design. So I've got a short introduction here, and I'd just like to start with a land acknowledgement. The offices of Sustainable Buildings Canada are located in Takaronto, which translates from Mohawk as the place where there are trees standing in the water. Takaronto is part of the treaty lands and territories of the Mississaugas of the Credit and is the traditional territory of the Anishinaabeg, the Wendat, and the Haudenosaunee. Takaronto is within the territory lands protected by the Dish with One Spoon Wampum Belt Covenant, which is an agreement between the Haudenosaunee, Anishinaabeg, and allied nations to peaceably share and care for the resources around the Great Lakes. And today, Takaronto is home to many Indigenous people from across Turtle Island. SBC is committed to truth and reconciliation and to honoring the Dish with One Spoon Wampum Belt Covenant, and we gratefully acknowledge and express gratitude to be able to live and work on this land. And I would just like to acknowledge the land I join you from today is the traditional and treaty territory of the Mississauga Nishnabeg. All right, so here's a brief agenda of what we're hoping to accomplish in this short time today. For anyone who has joined in the past, we typically try to keep these to 1 hour. Today we're planning to go over by a little bit. We've asked the Dialog team to speak a little deeper about the Hive project, in part because of the work we're doing on the mass timber costing guide, and I'll speak about that in a moment. But first, we're going to be starting with the branch team, giving us a bit of an insight into how this new platform they've developed works for structural design and how it can help with mass timber. So I'll give a bit more details about our presenters a little bit later on when I introduce them, but I just right off the top want to thank you all for agreeing to do this webinar with us and joining us today. All right, so Sustainable Buildings Canada, as most people on the call know, we are a not-for-profit that is focused on transformation of the building sector. So our website, we have lots of resources for new construction and including some of the resources I'm showing right there. We are always supporting research, so please, if you are working on something, you need a little bit of support to get a particular research project moved forward, that is something that we support financially. So send your proposals through to me. Check out our website for the types of work that we have. And then one of the projects that we work on a regular basis is the Enbridge Savings by Design program. So if you have any projects you're working on that are fitting into either of these categories you see there, affordable housing projects or commercial and multi-residential, meaning effectively any building that is not an affordable housing and it's not an industrial building, please check out their website or reach out directly to us. We provide an integrated design process workshop that gives a huge design input to your project, helps you find energy efficiency measures that can improve the energy efficiency. Our goal is 20 to 25% better than code as a minimum threshold, depending on the program. And for affordable housing projects in particular, there are follow-on incentives of up to $120,000 based on the number of doors or rooms assigned as affordable housing. All right, and then existing buildings. We have lots of resources for how to improve your existing buildings as well. So again, if you have research on how to do that, please reach out to me. If you go through our resources and you see something that maybe you can contribute to that breadth of work, we are happy to support that. One project that we are working on right now in the existing buildings space is the Better Condos Boot Camp. So this is an effort that is funded by TAF, and so just focus predominantly in the GTHA at the moment. But if you are involved in condos, if you do work with condos and see a way that they can improve their energy efficiency, please reach out to us. The intent is basically we are organizing large workshops with as many as 90 people from condo boards around the GTHA, focused on how they can understand the rules around their equipment replacement and how they can do better than replacing like for like. So this was the genesis of this program, was realizing that condo boards feel stuck when they are looking at trying to improve their energy efficiency, because the rules that they are bound by often tell them to replace like equipment for like, which means they're never able to improve their building efficiency. They're only ever able to do the bare minimum. So the Better Building or Better Condos Bootcamp is focused on teaching them how they can operate within their regulatory structures while finding improvements to their energy efficiency. How can they do deep energy retrofits? How can they do shallow energy retrofits? There's a lot of room for them to maneuver. So if you're interested in that, please click through that link. You'll receive all of these following the workshop. If you just go to our website or search Better Condos Bootcamp, you should find the right info. All right, and as I said, you will receive following the webinar all of the presentation decks, including this one. So you'll have all of these links. The videos will be uploaded onto our YouTube channel, so we keep a recording of it there, and we'll send a link out to everyone who's on the call, so you can have those links in the slide decks and the contact for our presenters. During the webinar, I keep saying webinar, you might have noticed, we've basically organized this as a Zoom meeting rather than a webinar. We find it's easier to get people engaged. If you have questions, please raise your virtual hand. We will call on people to ask questions. So basically the way that we're organizing it is our presenters will present. If you have a question that comes up and you'd just like to get it out there so we can see it, put it in the chat, and I'll either read it out or call on you to ask the question once we get into the Q&A portion of each presentation. So we'll do that presentation with Q&A, the next presentation, Q&A. All right, and then finally, I'd just like to say this particular webinar is supported by Natural Resources Canada. It is part of our mass timber costing guide work. That is, we gratefully acknowledge the support of NRCan's Greener Construction Through Wood program. Miranda Williamson and Martin Tovet have been quite supportive of this process. And so what we are doing here is we are working with RDH Building Science to produce a guide that is helping developers and others within the building industry understand the unique costing processes related to mass timber. So we're trying to speak to people who have a great deal of experience in building construction, but they have not been able to crack the methodology on mass timber. There are a lot of misconceptions about how mass timber can be used, what needs to be done to get it through to construction. And we are lucky to have these two groups of presenters here today, both of whom have lots of experience with mass timber, and most importantly, are able to help us clarify some of these misconceptions. Luckily for us, I would say the Hive team, Dialog in particular, have done a lot of work educating a great deal of the Canadian building industry about this project already. So thanks in advance for the contributions to this guide. So keep a lookout for that. We'll have it on our website, and we'll be doing, once it's complete later in the spring, we'll be doing quite a lot of outreach to try to get this in front of groups like yourselves who are interested in mass timber and not quite sure how to proceed. All right, so our presenters today, so we first off from the branch team, we have Andrey Dimitrov and Lily Huang, who will be presenting about this system. If you haven't already checked it out just from the promotional material, I encourage you to do it. It is really, really quite a cool system. We used it to help develop our archetype that is part of our mass timber costing guide. It's really quite a versatile system that it sounds like it's continually growing and adapting based on the technologies that are coming out and the products that are available. So thank you both for being here to present today on this. And then following that, we'll have Lindsay, Duthie, and Justin Tompson from Dialog, who have spent the better part of a decade working on the Hive project, bringing it through to construction and seemingly educating every single person on the west coast of Canada on how to deal with this type of really incredible structure. So, with that, I am going to hand things over to Andrey. Um, if I stop sharing, Andrey, you
Yep,
should be able to start sharing.
exactly. Let's give this a try.
There. So we're seeing it sort of
All right.
in the window there.
Yeah, sounds good.
Okay.
Um, All right. Yeah. So let's get started. Well, thank you for having us. My name's Andre. I'm the managing director of Branch. I'm joined with here by Lily, who's our senior product manager. And yeah, we're gonna talk a little bit about what we've been up to, the platform that we're building, and hopefully answer any questions you may have. Just in before we get really dive deep into it. I want to mention that Branch is a tech startup that is incubated inside of StructureCraft. You may know StructureCraft as a structural engineering company and a fabricator and builder of mass timber components. We were born out of a necessity in that company, and we are now going to show off the platform that we've built that is not only for StructureCraft, but it's meant to be for the AC industry in general. So yeah, have a little brief intro about Branch. Then we're going to talk about Branch Concept Lite, which is the app that's currently available that you can go on our website and try out for free. And then we're going to talk about what's coming next, which is Branch Concept and the beta phase that we're going to be opening up in a month or so, where we'll have a much more capable app and that is way more integrated and has a lot more features. So Branch is a platform that has a goal of redefining how we design, engineer, and detail buildings. And we want to do that through a holistic view. And by holistic, we mean the entire design process from feasibility to fabrication, and holistic in terms of the people involved, and whether it's architects, engineers, developers, and suppliers, and bringing all of that knowledge into one platform so decisions can be made both smarter and faster. What we offer is real-time structural sizing and optimization, where you can clearly, seamlessly transition from high-level concepts to low-level details of fabrication, and be able to make decisions very much upfront in the process, increasing speed, increasing certainty, transparency to all stakeholders. So how did we came to be? Well, we were born out of necessity. StructureCraft is a large engineering company. They have built over 10 million square feet of mass timber projects across hundreds of projects around the world. We started Branch to really help the internal processes of StructureCraft, going from complex geometry to seamless manufacturing. And through our life, which Branch has been around for about 2 years, internally to StructureCraft, we've been instrumental in powering over like close to 1 million square feet of projects so far. We've been instrumental in projects all over the world with high degrees of complexity. Uh, and the first product that we created was called Detailing, and that is the internal product that brings together the ecosystem of software that we have to deal with, from anywhere from Rhino to analysis software to CAM software for manufacturing, and bring that together in a holistic way. So that was the initial first years of Branch. Now that we have done that, we are tackling the other part of the equation, which is the early stages of design and concept and conception, with branch concept. And that's what we're going to talk about for the rest of the presentation. And branch concept aims to bring another chunk of the ecosystem of software together that relates to structural analysis, schematic design, early design, and brings everything together. So for branch concept light, the first thing I would ask, if anybody hasn't tried it yet, you can just go on the website right now, click on the try button, and you can start playing around with it. I'm gonna then play a video and sort of talk through the features, but I encourage you guys to multitask. It's totally fine. We do it all the time. Uh, um, yeah, just start playing around. So let me start this video from the beginning. Okay, and this is what you'll see, really, if you go to the website right now. This is the glimpse of Branch Concept Lite, which is our proof of concept of our initial platform that is meant to be external facing. So anyone in the AEC industry is welcome to use it. It is a super intuitive, quick way to model out a building and to get real-time feedback, structural feedback on sizing, get feedback on metrics like carbon and takeoffs, and really just play around. The point of it is to educate, to discover, to get it to for anybody to develop an intuition on how structural systems, specifically timber, behave under geometric conditions, and yeah, you can also try out different materials. The really cool part about this is that you can start getting a sense of the trade-offs when you move from material to another and really see the impacts of going mass timber versus going steel or concrete and anywhere in between. It's part of the education process. It's part of the stakeholder management when you're presenting to a client in order to show them those trade-offs about the material systems in a building very, very quickly. I'll just let this play a little bit. So yeah. So what do we again? What do we do? Why are we doing these? First, right off the bat, it's really about accelerated design and decision making. Having that real time feedback around sizing makes for quicker iterations, quicker understanding about what's happening. Comparisons are key here, showing multiple different versions of design options, and seeing how we can optimize for different metrics. This all starts making a lot of sense when we actually integrate suppliers into the mix and have actual real data about inputs, construction constraints, different carbon footprints, and eventually pricing as well. And finally, uh, there's unified metrics around takeoffs and also carbon that really is going to help out kind of seeing the full picture of the design very early on in the process. Okay, and then moving on to what we're working on right now. So what you're currently can play with is what we believe is a proof of concept. It gives you an idea of what we're going to be capable of, but the what we're working on now is the fully featured version of that, where you can actually model a full building, have a lot many integrations and features that would allow you to use Branch in real projects very soon. And we're going to be opening the beta phase of this tool in the next couple of months. So I wanted to just to show you some of the features that we're working on. First of all, we're going to have a very detailed introspection of the analysis, specifically catered to structural engineers. Now, you might not be a structural engineer and you might not care to see all of these charts and numbers. But what makes Branch very effective is that we can build trust with engineers so that you know that whatever sizing comes out of it your engineer will also agree with. So it is very important for us to have that connection, whether you care about the details of analysis or you don't. Knowing that you can trust the platform is extremely important, and we want to create all the tooling so that engineers can also see what is happening under the hood. We're going to be expanding our metrics and getting very deep into the details so that you get a very quick, immediate feedback on what is happening in your building and look at specific metrics that you care about. So that's going to be again catered for you as an architect to start off, or as a structural engineer to get deeper into some details, or even as a developer to understand some key metrics about the building. And finally, I would say this is a feature that we are spending probably the most amount of time working on is optioneering, is making it easy and intuitive to compare different designs, different decisions together. The branch platform is essentially material agnostic, meaning that we can handle not just mass timber, but steel and concrete and any combination. And even if you're designing a mass timber building, uh, different materials are critical. First reason, mass timber buildings are hybrids anyways. There are parts of them that are steel and concrete. And for the second reason is that you want to see those different options. You want to be comparing and talking to a client about the different trade-offs between different materials. So having that all in the same system is critical. And that is one of the major features that we're going to be improving there. And what you see on the screen as well is that this is a real building. Branch Concept Light is a fast massing modeling tool, but it cannot handle real building geometry complexity. And Branch Concept, what we're going to be launching as beta, will be able to do that. So we very much look forward to seeing people model their like actual real projects and start integrating Branch into their workflows. So that was it. I wanted to make it really short here. Again, thank you for your time. If you're curious about joining the beta, please sign up on our website. You can always start a conversation with us. Send us an email. But yeah, I wanted to just spend a bit more time for the QA portion of it of the session. Would love to hear from you guys about how you're managing structural constraints very early on in the process in conceptual design. What is that conversation between the trade-offs in terms of carbon and pricing that you have with clients, your interactions with engineers along the way, how early do you involve them in the conversation? Yeah.
Excellent. Thanks, Andre. So I appreciate this. The questions that you just asked. If anyone has any questions related to that, any comments, any insight, I'll say through the development of our mass timber costing guide in our what do we call it? Consultation process within the industry. That was, these are some of the key points that came up. Was it's difficult as a designer to start working on a design of the building not knowing the specific fabricator, because each manufacturer has their own limitations, and so this is why this tool was very helpful for our team to sort of find a way where we could make a generic archetype in a way that would fit with different manufacturers and allow that flexibility. So I'm wondering if anyone else has any input on that, any questions, comments. Just give everyone a moment to, if you have any input here, any questions for the team, please just feel free to open up your mic. Sonia. Go ahead.
Thank you. Thank you for the presentation. Just with regards to, yes, this is specific to sort of structure craft needs right now. It, what are the realities around incorporating other mass timber producer product profiles? And how would
That's a
that
very
get
yeah.
maintained moving forward and so on? I would expect that there's some proprietary angles to that.
So that's a very good point. Yeah, I do want to make a distinction quite clearly that branch concept is something that is not going to be like inherently linked to structure craft. We want this to be used by the AC industry in general. We have already a set of suppliers integrated into the platform that are different. Like Element 5, for example, there's I think five or six of them already. And we are making it easier for suppliers to get visibility on the platform, basically upload their data, their products so that the users can just choose whatever combination they want. So it's going to be very much agnostic to that. Structure Craft is not really kind of powering this in the background. Yeah.
Great. And then costing, sorry, this is now I'm trying to connect the dots between the
Hmm.
tool and then Adam, the work that you're doing as it relates to costing. Costs are always changing. Um,
Yeah.
how does one visualize that?
We haven't really turned on costing for the platform at the moment, but as we get more suppliers into the onto the platform, they would be managing that themselves,
Hmm.
so that whatever costs they want to show on the platform, that's what would use. So that's something that we want to just really hand off to each supplier to manage the kind of data they want to add to the platform and maintain that. Yeah.
Great.
And
Thank you.
I'll just
Sonia,
add a
if I,
little.
oh, sorry, go ahead.
Oh,
Yeah.
sorry, Adam. If I
Go
may
ahead,
just add a
Lily.
little bit of color to the
Hmm.
question. So there's the element of supplier costing, but there's also kind of costing overall from one project option to another.
Mhm.
We are very excited to help you guys figure out costing. I know that's like a big pain point across a lot of projects in terms of decision making, but it's actually obviously complex to dial that in without oversimplifying it, right? So, in order to not mislead anyone down this path that there's accurate costing coming out of branch, we were thinking about including bill of quantities, volumes, and a breakdown of like how many like piece counts by element, and having that be a proxy for the designer to have that conversation of what optimization or cost looks like for each project, because that can be very project specific depending on the
Yeah.
goals. So we're hoping to kind of show you the data, and then, of course, if there's any feedback as you guys use the tool on how we could add to that to kind of get closer to that hard cost, we're happy to have that conversation, as Andre said.
Perfect. Thank
Yeah.
you.
There was also a comment about TimberX and MT Navigator in the chat by David. I'm not aware of MT Navigator, so I'll have to look into that, but I did play around with TimberX, and I would say the differentiator is TimberX, as I've played around with it, is more like a bay tool. So you can kind of compare cost across a simple bay. The tool that we have would allow you to build in your project. So even with Concept Light, there's more sophistication in the geometry. And with full concept, as Andre was showing, you could start looking at different materials. So concrete podium, timber tower, all concrete versus timber. So it has just more functionality for you to kind of get your project specifics, and also be able to do that comparison.
Excellent. Thanks, Lily. I'll just add in that for our purposes, and Jay, please correct me if I'm getting any of this wrong, that the key for us as we used it in our project was not to get costing out of it, but it was that we were trying to strike a balance of a building that could be used across Canada as the basis for a costing study. And so it was really about finding something that could be adapted to different manufacturers' specific, typologies, limitations, and so really that's how we used it. Jay, anything you can add there?
That's a great summary of our use of the tool. And to follow on to what Lily said, there's also the FastNet tool, which is also a Bay design tool. The issue there was we ran into limitations with physically how large you could make the model, which did not suit our archetypes for this situation. They'll all have their pluses and minuses, and they're all slightly based on different codes and so forth. But by far, this was probably the easiest tool that I encountered in order to quickly put together a reasonable archetype for our purposes.
We're looking forward to making it even easier for you, Jay, in the
Yeah.
future.
Well, I appreciate all of your feedback and assistance as I've stumbled through this process.
No, you guys were great. Happy to help.
All right. Well, thank you both thanks for the presentation and the questions. We're going to turn our attention now to the Dialog team. If anyone has any other questions for Andrey and Lily, feel free to put them in the chat, and we can sort of answer them as we go. All right. Excellent. And then, so Lindsay or Justin, whoever will be sharing the screen, you should have access to share now.
All right. Thank you. Okay, here we go.
There,
hi,
looks
everybody.
good. Sounds good.
Looks good? Okay,
Take it
thanks.
away.
Yeah, hi, everybody. We're here to talk about the Hive today. So Justin and I are from Dialog. We're based in the Vancouver studio, but Dialog is an integrated multidisciplinary practice with locations across Canada and the US. Today, we're kind of going to give an overview of the project, and then we're going to dive into we're going to go by phase to kind of talk about some of the lessons learned that we've picked up along the way, and then cap it off with an overview of some of the project successes. So I'm going to start with a project introduction. So our site is located in East Vancouver. It's located in the False Creek Flats neighborhood, which has historically been quite an industrial neighborhood that's more recently going through a revitalization. We're seeing lots of sort of creative headquarter buildings going up in the area. Here's a snapshot of the existing site. This was a really sort of derelict space. You can see the art piece there. It's sitting in the shadow of this art piece called the Monument to East Vancouver. And our site was very complex. It has a 12-meter grade change from Keith Drive to Clark. We're right up against a SkyTrain station, as you can see, VCC Clark SkyTrain station there. So we had those setback clearances that were required. We also have the future Central Valley Greenway dedication along the south there in green. And then we also had I think a 100-year-old sewer line that's running diagonally through our site, which could not bear any load. So these were some of the challenges we had dealing with the site. It's got some real advantages too. We have incredible views to the North Shore Mountains and to the city, and great solar orientation, as well as great accessibility given we're along a bike route and next to the SkyTrain station. So this project, it's been pretty visionary right from the get-go. We knew early on that the structure would be mass timber. We started out in the design team by looking at a post and beam scenario, but we also wanted to explore what innovations were possible. Fast enough are the structural engineers on this project. And so we did some exploration, and ultimately we decided to take the seismic resisting elements and move these to the perimeter of the building in the form of brace frames. So this did a number of things. It opened up our floor plates to be really open and flexible, which is what you want for office use. It allowed us to approach the core differently. So this project does not have concrete cores. In fact, it doesn't have any concrete above the level 2 slab, except for the concrete floor topping. So this really helps to drive down our embodied carbon emissions. And then with those brace frames, we took an approach where we mirrored them in alternating locations, and this gave us the kind of honeycomb expression that you can see today. So the brace frames are highlighted here in blue. The way the geometry lands, we have an even number of them around the perimeter, which allows the pattern to flow continuously. And as I mentioned, we don't have concrete cores, but we do have 4 CLT shear walls, and those are highlighted here in yellow. Exterior to the envelope, we have a balcony system, which mimics that honeycomb expression. So every level has access to the outdoors. So the balconies are on the east, south, and west faces of the building. They're at a 2-meter depth. We don't have balconies on the north, mostly because of those SkyTrain constraints that I mentioned earlier, as well as the reduced solar exposure. However, the honeycomb expression does wrap all the way around to the north side as well. So pulling this apart, the building consists of 4 levels of underground parking. We have a concrete first story. We have a tall floor to floor on the first level at 6 meters. And because of that slope I mentioned, concrete just really made sense here. And then above that, we have 9 stories of our mass timber structure. And then finally, the honeycomb exterior expression through the balconies. We worked with a pre-construction consultant on the project. This brought a lot of value. One of the things we discussed in the early design stage was our construction sequencing. This diagram kind of speaks to that. So we'd have the mass timber structure followed by a unitized facade. This allows the building to be enclosed quickly, which is very important in Rainy City. And then we've got a thermally broken HSS stub out, which acts as the connection point for the balconies, which are then added on after the curtain wall. Here's a rendering from the design stage. As you can see, it's a pretty simplified facade palette. We've got silver metal panel, CLT balconies. Yes, we are using real wood at the balconies in the soffit condition, so they are weather protected. And our curtain wall, which is triple glazed curtain wall, both fission and spandrel glass. Here's a look at the general arrangement of the building. It's 165,000 square feet total area. The ground floor on the top there consists of the lobby. We've got end of trip facilities. We've got bike storage, a loading bay. And then the image below, this is our typical open office layout. This is a core and shell building, so a lot of what we're speaking about today is about how we design for, real flexibility in the future fit out scenarios. So the open office layouts, the typical levels are 18,500 square feet. And the grid spacing is 6 meters east to west, and then 8.2 meters north-south. I'm going to hand it over to Justin to talk about owner's perspective.
Great. Thanks, Lindsay. Justin Tompson. I am a principal associate at Dialog and have been the project manager on this project since late 2018. And what Lindsay was talking about, in particular with the floor plates, was all fairly conventional, but where things were unconventional, we had to have that buy-in by the owners and owners reps as well. The owners themselves, they are a natural food company, so the ethos of the building they bought into quite early with us, but the developers, development managers have developed, managed millions of square feet of conventional office space. And so going to a mass timber was unique to them. And there was a lot of learning and having to buy into the concept of this all the way along. I'm going to speak a few of the more softer items here and then pass back off to Lindsay. So one of them, of course, was insurance. A lot of what we were doing, there wasn't a code or a plan or a script for this that people understood, everything from the insurance to the constructors to the trades. So on the insurance, initially when this was coming, getting assessments, the owners were getting assessments, it was going to be coming in at 3 times a conventional building because the insurers didn't have any context. They were looking at this going, well, this is a wood building. You're not encapsulating it like UBC tall wood. What do you mean? And so they're having a hard time wrapping their head around this. So we had to demonstrate some measures on how this is being managed and provide some reports back to the insurers through the design stage through to the construction stage as well. And they did bring that down, but we'll talk about some of our partners on the project, and Enercan was able to provide some assistance with the insurance portion of that as well, because the Enercan funding that the project did receive was to offset some of the unique costs that are occurred on this project that are different than a baseline conventional concrete or steel building. Next slide. So leasing risk or perception of risk. Bentall Green Oak was the development manager. They were looking at this and through the design, they really grilled us and just they needed to understand how, if they became the leasing manager when the building was complete, how are they going to be able to sell this building? So to the left is a conventional office building that we're all used to. A regular either window wall or curtain wall, a drop ceiling where all your services run, a sill, and some form of either underfloor or through the sill or through the ceiling distribution of power and data. Well, on the right is an actual photograph of our building, and it doesn't have any of that. So the intention of all the services was really key, and Lindsay's going to spend a bit more time on that. But it was, having the president of BGO and vice president of development from BGO just kind of ask us, well, where is, how will a Microsoft get in here and actually be able to lease this space out? Where will their services be? Where will their cores be? Where will their washrooms be? So we went through that and had to explain that there was a certain amount of flexibility built into this building, but not the same as a conventional building. And so this is a unique product on the market, and that was seen as both a challenge and an asset from a leasing side. Next. And then during construction, it was trying to understand the cash flow. This was a unique one. Picture here is of Kalashnikov's works yard in Castleguard. They produced all of the mass timber. They were the subtrade under Ventana for all the wood. So what you see is typically this might be one lot for a conventional building or a building like Keith Drive, but their portion of the contract was mostly done on their site before it's even shipped, before even a stick of wood actually landed on site. They had progressed under the schedule of values close to 85% of their portion of their subcontract. So having the owners understand that, wrap their heads around that, Fast Temp is really good to explain that is conventional, because the labor of the erection was actually just a very small portion, but all of the acquiring the product, pressing the product, the logistics of getting it ready to ship was the bulk of the work. So anywhere from 75 to 85%, if you're seeing a progress draw where that's showing that high percentage and you haven't even seen a piece of wood on site yet, that was the one unique element that we had to wrap our heads around. And in conventional contracts, CCDCs may not be written up that way to understand that. So, usually when you're talking about a particular substantial completion or even progress, it's supplied and installed. So there either has to be some understanding of that process or looking at your contracts, making sure that is written into it. It's not the contract is not seen as being non-compliant with those requirements. Next slide. And then on building operations and maintenance, we had to convey some information about how this building was going to be maintained. Again, BGO just asking the questions. Lindsay mentioned that the balconies are structural CLT wood. What you see on the underside of this. We did a lot of investigation with coating manufacturers and sealing and for structural mass timber as well as finish coating. We wound up with a Sanson KP12. We've used this on other projects as well. It is deep penetrating sealer, deals with spiral mold growth, and is used for structural engineered wood that's left exposed to the exterior. It gets put on in the factory and helps with shipping and protection of the wood during construction as well. And then we've got two layers of top coat and end coats and wax and such. But again, what this product will say is their warranty or their expected service life versus what they say it actually will do. They would never really put on paper how long it would last. They say it will actually last a lot longer than they're able to paper, but there will be a maintenance of that that'll be required at a certain stage. We did a lot of great detailing to make sure, as you see from the flashing along the edges there, that we've got returns, weather protection, venting, and membraning of that above on the roof deck. They're fully covered from wind-driven rain, but there may be some sun reflection that'll come off the windows. So in the service life of the building, they may need to be recoated. And then the other piece was we installed a roof detection system on the roof, a leak detection system on the roof. So we've got an electronic leak detection system all across the roof, because all of the roof is wood. The occupied roof deck on level 10, as well as the full roof above that, is all wood. So this system goes all throughout. Slide. So again, more on some of the other softer processes, the authorities having jurisdiction in the development permit and building permit process. On the development permit side, we had a lot of challenges. Things came in, code changes, but for the most part, it wasn't really specific to the mass timber typology itself. It was just things that any project could see. We had turnover at the City of Vancouver. We had code changes. We had advanced transportation demand management codes that came into play. But that could have been with any building. So there wasn't anything very unique about the mass timber element of this. But on the building permit side, that was a completely different game. The city really had very little context. The code hadn't changed, allowed for multi-story unencapsulated, and we were going to 10-story unencapsulated, which the city hadn't seen before. So we had to engage both modeling and research on historical data. We had engaged Dr. Stephen Kraft out of Ottawa, wood specialist, who went through and scoured through data from CSA tests from the past to see if there's anything there. A lot of it wasn't fully applying. And so we actually had to do a lot of testing ourselves. So along with the theoretical modeling and documentation from our code consultant, Fastinet, and Dr. Stephen Kraft and Dialog, we also end up doing full-scale mock-up testing at the University of Alberta. You'll see some of the examples here. And on the next page, that dealt with some of the shear and seismic requirement. So we basically wrote the public data now that's available, because the city just really had very little context on how to work with this. One of the interesting things that came out of this full-scale testing is Fastinet tested their shear connections and shear plates through the brace frames. And with the full-scale testing, it sheared, but not exactly how they wanted it to shear. This was end of 2019. We're getting ready to go for tender early in 2020, as what we thought. And so we did a pivot. They proposed these different type of seismic dampers called the tectonics. They come out of New Zealand, largely driven out of the experience that they had with the Christchurch earthquakes years ago. And they are a tested product that allows for, in the brace frames and the shear walls, to absorb shock and then actually be able to right the building as well. So those actually went into the building in lieu of redesigning the shear plates. So that became part of the tender package. And then unfortunately, things went on hold early 2020. We were on hold for about 16 months while COVID happened, and then went for tender and started construction shortly after that. But all of this data we went through, we sat down with the City of Vancouver, their lead building inspector, the fire department from City of Vancouver, and went through all of this. And next slide. And then also some of the alternative solutions that we're starting to form up as well about the char depth that we had to add to the wood. So there's all of the mass timber has additional 90 millimeters of char depth built into it to allow to take that first char from a significant fire event, and then it will self-extinguish and not continue to burn. But we also had to provide a backup water cistern and pump room for the sprinkler system. So in a seismic event, if the water connection from the city is sheared, this is a 2-story water cistern in the parkade and fire pump on the emergency generator that would be able to sprinkler the building in case of an event. And then some of our project contributors, NRCan provided some significant funding for the project, which really helped offset a lot of these additional measures. Forestry Innovation Investment also provided some funding and continues to, and FP Innovations, as well as Clean BC. So we're very grateful to these contributors. They really helped make this project a success in where we were breaking a lot of new ground with mass timber that the industry hadn't seen in the local market. Okay, I'll pass over to Lindsay now.
Okay, I'm going to touch on some of our MEP integration. This is something that I think we worked really hard on in the design stage, and it's what I think is something, it's a great success in the project. So we had high ambitions to create a really tidy ceiling, and we also didn't want to go with a raised floor. So we came up with a strategy working with our design team and consultants where we integrated service distribution channels in the ceiling. So these service distribution channels are highlighted in blue, and then they are distributed from a central bulkhead, which is highlighted in yellow. The central bulkhead is a drop ceiling that contains fan coils, cable trays, etc. We achieved these channels by using three-ply CLT panels at the midpoint between the grid lines. And then we have the 9-ply on either side of that, so we create a void. And that's where the services are run. You can see the detail on the right. We've got the three-ply CLT, 2 layers of Type X gypsum for fire protection. Our services run down there, things like our electrical or lighting, occupancy sensors, some sprinklers, etc. And then we've got a perforated metal panel that closes that with a layer of acoustic blanket in behind it. There was really great effort to design and coordinate and draw the services intentionally rather than indicatively in the design stage. And then great effort during construction to make sure that all of these services were laid out correctly. And then in terms of the floor, we do have a walker duct system. These are highlighted in purple. This is integrated into our floor topping, and this allows future flexibility for the tenant fit outs to have power where needed at the perimeter sill wall. We do have one level that has raised floor. This is on our level 10. This is a unique condition. It really just was implemented to allow us to have that nice seamless transition out to the rooftop amenity patio deck there. So you can see an image here of our rooftop amenity space. So here's an interior rendering during the design phase. During construction, here you can see the alternating panel strategy to create those voids. Starting to see the services going here with that Type X above. And finally, this is how it looks today. You can see the bulkhead there on the right. We do have sidewall sprinklers, and we do have some stub outs for the spiral ducts that will be implemented during the tenant fit out. Okay, we're going to talk a little bit more about construction.
Yeah, thanks again, Lindsay. Yeah, one of the interesting things that we did through the design phase, Fastenep really knows the mass timber producers really well, from North American to European markets. Initially, it was set up that the largest pieces of wood, the shear walls, even the floor panels, we want to make sure that we could be competitive in the bidding. We were not into COVID yet. There was a lot of escalation happening. So we want to make sure that we had the best product and the best price in order to get this building built. Initially, the concept was to use a 3-panel shear wall that goes all the way up through the building, stitched in 2 places. And that stitching would be on the encapsulated side of the cores, which would be the stairs, elevators. And then the exposed side into the open office areas would not be stitched up. Once we knew who the primary contractor was and their trades, in the first few months of the project, we went through this exercise with Fastenep and the trades, Klesnikov, the primary sub-trade, which is George Third and Sons. They did all the steel, and Klesnikov was a sub to them. Just worked through and looked at, one, how big of a panel could we actually get down a road and put on a truck, and how big of a panel could you press? And we're able to refine that and turn that into a 2-panel system, a large panel and a small panel. These shear walls, they span 3 stories. And we knew exactly how we could actually get those to site through that whole process. So it was a really integrated process, working early on with the consultants and the trades to make this happen. So these are the first 4 shear walls that Lindsay had pointed out previously in the yellow slide, the highlighted yellow in the floor plan slide. So these are, for scale, these are 3 stories tall. Supreme Steel was the erector of all the mass timber, another sub under George Third and Sons. These first 3 panels were stitched together in their plant in South Burnaby and put on a flatbed truck and trucked to site at the wee hours of 3 or 4 in the morning in a mid-March day with police escort because they were super wide load. The remaining 3 other lifts of panels above that, they actually brought them in the 2 pieces and stitched them on site and then lifted them in place. The logistics of doing these was rather onerous, but for these first 3, it was critical to get them lifted in place. And again, back to these tectonic plates. This was the terminus or the bottom of this. This is on level 2, the top of the concrete, as Lindsay had mentioned previously. This big inverted triangular shoe sets the shear walls, and then there's these tectonic seismic dampers on either side that allow the shear wall to dampen any seismic forces and then be able to right itself. This is not a post-disaster building, but when we were explaining this to City Vancouver and the fire department, they were quite impressed with, one, all the fire testing we had done as well as the seismic, and felt that this building was about as close to a post-disaster as you could get for a mass timber building. And it allows the building to potentially be reused after a major seismic event where a concrete or steel building will deform, allow the people to get out safely, but maybe need to be deconstructed as it may not be able to be safe for reuse.
So post-tender, excuse me, we started doing weekly meetings with the trades to review constructability, identify clashes and efficiencies. So this is an image of the fabrication model. This one's showing the steel and timber. This is by Apex Structural and George Third and Son. This was a really beneficial process to get together and have these meetings early on. This is when the site was kind of being mobilized and going through excavation. So it was the perfect time to get together and identify some of these efficiencies early on. Here's an image from that model showing all the steel in the project. And then just, diving in a little bit to the balcony structure up top, you can see our drawings, and then below is what was prefabricated. The trades elected to prefabricate the entire balcony structure, so including the CLT panels, the vertical posts, and the guard supports. And these are quite large. They're 2 meters deep, and then they're 2 bays wide, so they're 12 meters long. Here's an image during construction of that curtain wall flying up. You can kind of see the HSS stub outs. We'll look at those in a moment. Justin, do you want to mention the roof?
Yeah, I'll just add on to this as well. There was a lot of innovation, as Lindsay was showing by that detailed model. If you think of 10, 15 years ago, shop drawings would come from one trade, say by others all over it, and pass on to the GC to coordinate that. Well, they actually use this digital model in real time, sharing it, so they were able to get into that minutia of the detail of how this all got to come together. On the design side, during FastNet and Dialog worked really hard on these work points where the balconies connect. So there's very limited areas where the balconies actually do penetrate the curtain wall, and it's just at those work points. Everywhere else, the shear wall, the curtain wall is contiguous all throughout. So that allowed the structure to go up and the curtain wall to follow quickly afterwards, and then the balconies were put on after the building was tightened up. But in order to facilitate some dry work, this construction happened over a number of years, as you'd expect. The contractor also elected to put in a temporary roof on level 6, instead of just using the thinner waterproof protection Rothblast material. They actually used an SPS, put it on there so that they could actually partially button up the building and starting to do some of the dry work below, equipment installation, and even some of the drywall work in the lobby and working their way up. And allowed them to expedite some of the work. These are the work points I'm talking about. So we had designed, as you see on the slide on the right, a thermal break at the curtain wall insulation, the spandrel insulation location. The steel contractors said, well, that's too tight of a pocket for us to connect our balconies onto. So we want to do a second work point further out, so that when we fly the balconies in, we don't have to worry about sort of threading this needle and getting the stub into that little pocket there and trying to bolt that in. So they devised this plan to have this intermediary plate. So we've got a thermal break at the insulation, and then I see on the left is actually their work point of where the balconies came into. And as Lindsay mentioned before, we did the first mock-ups of just the structure of the balconies, but then they again elected better quality control to do all the insulation, roofing, the steel frame of the balcony above the CLT, and the shoe for the guardrail all in the shop. And then when they brought this out, all they had to do was tie in the membrane insulation at the work points and do the cladding on the outside. So I think they take the installation of the balconies down from 12 or 15 weeks to about 3 or 4 weeks in total. This was the mock-up of the balconies, the in situ mock-up. So this wasn't the fully insulated one. This was the only location where they didn't have it all prefabricated. Only the structure was prefabricated, but this shows how this all went together. Worked really well with the trades and the consultant team to make sure that all those work points came together as expected. And it's just more demonstrating how that was able to rise up and how to utilize that level 6 temporary floor. You can sort of see the level 6 is where that dips down in the middle. That's about where the temporary roof was, and then they're able to do still some of the wet work above. And then again, the contractor also took the initiative to, on the roof assembly, swap out the lighter air vapor barrier to actually do a heavier gauge 2-ply SBS membrane for the AV barrier, and then use that, and with the protection board, use it as a working deck. So they didn't actually have to install the full roof system to actually get waterproofing for the levels below. Yes, there was some sideways rain that they had to deal with, but it made their water management a lot easier going forward. And then onto water management. Everybody wants to know, how do you build a mass timber building in a rainforest? Well, we had a very robust mass timber protection plan specification that evolved into the construction mass timber protection plan. Our spec is on the left. The contractor is on the right. And it shows, along with not only products and procedures, they had plans mapped out of exactly how they were going to lift, protect, do temporary measures, do soft drains, from some of the areas within the floor plate to the windows when they're starting to do the membrane, starting to do the envelope on the exterior, and just how they're going to manage that. So they had protective measures to keep the rain off the floor, but that wasn't always possible. So then they had active squeeging into roof drains that they had put into the splines. Lindsay showed those channels where all the services run. So before the drywall and the channels were there, the 3-ply splines are able to cut holes and then put a temporary roof drain and run a soft hose out of that, out through the window or out to the exterior, and let it drain outside of the building. And then it also evolved as they got up to the roof. One of the lessons learned I think we took away from this is, in the mass timber protection plan specification, there was a lot that we left to means and methods of the contractor. Looking back, we would change one word in almost that entire spec. We would change may or to shall, and actually make prescriptive so that the price is absolutely built in, and leave less things discretionary to the contractor. Although there was a lot of trust with their GC, there was a lot of things that was new to them as well. So they were learning as they went. So this Keter roof was one of the last elements that was put in for weather protection as they're finishing off the roof as it came into the fall of 2025, I believe, 2024. And just to protect all of the roofing that they're putting down. You can see on the right, they're putting down actually insulation and the final membrane for the roof, whereas the heavier, robust AV barrier that they used at the work surface was down below after they had all that, the wood surface dried out. Okay. And then one other of the unique things, every project will have some form of construction fire protection plan, but this was aligned with one of our alternative solutions. We actually had to have a rated stair all the way through construction. So we swapped out the conventional Type X gypsum wallboard to a Type C. So there was wet board and fire rated board as well. So this could be used for protection. So here's the contractor starting to install that as they go up. So this is just another additional cost that had to be anticipated in it, where we had designed for the final occupation and use of the building, and just anticipation of having this. Some of the alternative solutions took a little bit to get finalized with the city, because again, the city was seeing this typology for the first time, not only for the complete building, but also how it was going to be used and constructed safely during construction.
Okay, I'm just going to kind of quickly touch on some of the major project successes. This is a really high performance building. We're net zero energy ready. Some of the strategies we're using to achieve this, we've got a high efficiency air source heat pump, demand control ventilation, heat recovery. This is an all electric building, so we've reduced any reliance on fossil fuels in the project, which helps keep our GHG emissions low, as well as lowers our energy cost. That said, we do have a backup generator that uses diesel. There's no way around that right now in Vancouver. We also have energy conserving sensors, daylight sensors, occupancy sensors, and then the high performance building envelope, which we touched on. This uses a triple glazed curtain wall, which helped us to achieve our performance targets. And then, of course, the exposed mass timber structure. This is carbon reduction. This is structure as finished, so we reduce the need for additional finishes throughout. And what it creates is really a pretty incredible office environment that emphasizes principles of biophilia. We are on track for LEED Gold. We have Salmon Safe certification. In case you're not aware of that, this is a little bit more prevalent on the West Coast, but this is a certification that recognizes land management practices that better protect the downstream water quality off of sites, which then in turn protect our Pacific fish and salmon habitats. And then on the right here, you can see some stats from Canada Wood Council Carbon Calculator. The amount of wood in this project can be grown by North American forests in 42 minutes.
So by the time this presentation is over, another Keith Drive would have been grown.
Yeah.
Yeah, and we can't end without thanking all of the amazing partners and contributors to this project. We had an amazing design team. I think earlier on in the presentation, the structure craft talking about the when do you integrate with consultants. We had to integrate early because of, as Lindsay mentioned, all the intentional location of services. We didn't have a free-for-all just to run things in a dropped ceiling or a raised floor. So Dialog was architecture, interior design, and landscape design. HKA was the client's representative. Dental Greenup was the development manager. BK Projects was the project manager for both. Fasten Up, our structural consultant, of course, Amy, mechanical, AES, electrical. JHL is our code consultant and CP, certified professional in Vancouver. BVDA was our curtain wall consultant. EXP was our envelope consultant, and Troba energy modeling and lead. Gunn was our elevator consultant. Korea Civil, Geo-Pacific, geotechnical, of course. RWDI doing some of the water management assessment. Bunt was our traffic analysis through a development process. CES was our commissioning consultant. And Ventana is a general constructor, and all other trades, of course, bringing this to success. This was just a photo shoot we had done, just our site visit we had done close to the end of completion. And we had a lot of auspicious signs on this project. There's a crow flying there. If anybody knows Vancouver very well, the crows migrate from fall to spring from everywhere around the lower mainland to one area called Still Creek. So we had some crows flying by at sunset, and the sun poked up and gave us a double rainbow on that day. So we're quite lucky. When the Stevens, the owners of the building, had done the bottoming out and the bottom of the parkade, they put before the concrete is poured, they put a little memento in the ground and covered it up when we had a full moon in the daytime during that time. When we did the beam signing of the last beam on the roof as well, we had another full moon in the daytime showing. And then just earlier this week, we were doing a tour with some of the members of the city and the owners, and we actually had an eagle flying over top of the building. So you can read into it what you want, but there's always been lots of auspicious signs with this building, and we think that's a good omen.
That wraps up our presentation, so we'll open it up for questions.
Thank you so much. That was incredible detail. I wrote down so many things to ask, but we'll start at the chat. I see a couple questions here from Stefan, starting with the honeycomb design. Is it structurally needed or just design? And I think you spoke to that a little bit, but I'll let you.
Yeah. So the honeycomb design it's the lateral system, so it's a brace frame that alternating look every other location. So it's the structure, but then we mimic the structure with the external balcony system. So that's a direct reflection of the structural system inside the envelope. That helps clarify.
Yeah.
And then, sorry, go ahead, Justin.
Yeah, Martin, our architect of record, AOR and partner Dialog, he recalls early stages working with Paul Fast from Fast and Ep that, as Lindsay mentioned, when they brought the brace frames out to the exterior, he basically said, well, we're going to need one that goes down like this, we're going to need one that goes down like this, and then flipping that gave us that honeycomb shape. So it is form and function. Function started, and with just one quick little move, it created this amazing form while still achieving everything from functionality.
Yeah, it really is an incredible design. Okay, so another one from Stefan there about the balconies there, where you have it's sort of level on barrier. How do you remove water and melting snow in front of the sliding doors if it's on one level and barrier free? And then how do you ensure that the snow doesn't damage the door in sill construction?
Is this where we get to be glib and talk about the lack of snow in Vancouver?
Yeah, well, so there, Milana responded, it's Vancouver, so there's not much snow. But I mean, this is one of our goals, is to help take the lessons you guys learned, or you folks learned there, and, share them across Canada. And obviously, there are some parts of Canada where this would be under a meter of snow.
Yeah. The building does have a building manager, full-time building manager. So we haven't provided any snow melt elements within the outside deck as well. That could be something that could be achieved by, I don't know whether it's heat recovery or it's just tiles on pedestals with a insulated roof deck below. That'd have to be something that'd be looked at, or just active management, just like they had to do it during construction during the wet weather, or those bifolding doors. I'm probably assuming not too many people are going to be going out if it's minus 30 and wind chill factor. But yeah, there would have to be operations, the active operations throughout the life of the building, which this building does have.
Excellent. And I'll add something too. There's sort of a whole water story that we didn't go into in this presentation, but we do have a balcony integrated water conveyance system. So we collect and convey the water down actually through the balconies in a gutter system, and then it's sort of channeled through a landscape strip where it's filtered before it returns to the city system.
Oh, amazing. Yeah, that's we didn't have time to ask every single question, so I appreciate that.
Yeah.
So then the next one here is about the height. So you were able to go up 10 stories on this project, theoretically, with the same innovative structural system, work for up to 18 stories with that 8 stories of additional load, thinking about repeatability and opportunities for future office projects in denser areas.
Yes. So for this typology, and even a little bit to the comment or question by Lily, this was designed specifically for 10 stories. I mean, well, actually, an interesting story is that it was 8 stories originally in late 2018 when we're going to the urban design panel. They commented, they said, this is amazing. You're right beside an active transportation path. You're right beside a SkyTrain. Why not make it taller? Create more density. So we were like, okay, great, let's do that. So we added 2 more stories between October 2018 and February 2019 when we went to the DP board. Also added another level of parking for that additional capacity. So the sizing was specific to this, just because we had to go through all that seismic testing and fire testing as well. But Lindsay just posted a link to one of our sites. We've also got a patented hybrid mass timber concrete floor system that we're looking at for longer spans and higher towers. We haven't implemented this on a project yet, but we've been working with Elliston and other partners to do full-scale mock-ups similar to what we had done on Keith Drive, fire and seismic testing. We've got about a 4-foot by 4-foot panel in our lobby that's all charred up and beaten up that has the full-scale testing on it. And we're getting patent patented in multiple countries around the world. So looking for the next project to implement that. So if anybody has a tall tower, they want to do mass timber, hybrid floor slabs, you know who to call.
I'll add to that too. We have actually worked on an 18-story mass timber project in our office, although that used a different structural approach. It was a steel point support system, which we found had a lot of advantages and efficiencies. So whether this structural approach would work, we'd have to loop in our FastNet friends.
That's fair. That's the testament to a great and diverse team. So there's the one other question here about air tightness. What air tightness were you able to achieve on the building?
You know that stat, Justin? I know that the air tightness came back better than anticipated.
Yeah, I can probably pull that up in a second here, but yeah, it
Okay.
actually performed really well. And when we did all the commissioning, everybody was sort of blown away at how well it performed. And again, just a great team with EXP managing that with CS and the contractors. It came out better than expected.
All right, excellent. I mean, obviously, this as a group, I think, tend to be focused on the energy performance, obviously. So that is always something that comes up. So, Lindsay, you had a phrase that it was a new phrase to me. You said something versus indicatively in the design. So about I think this was about the channels.
Yeah.
Can you repeat that phrase and then expand on that a little bit?
Oh, I think I was saying there was great effort to draw our systems intentionally rather than indicatively during the design phase.
Yes.
Which I think if anybody is sort of familiar with working in the design phase here, sometimes our consultants will draw things as indicatively and then it gets figured out later. We couldn't do that here. Everything had to be very intentional. And yeah, I mean, even our RCPs even showed like what we would like for the spacing of where everything was coming down through those service channels. We worked very closely with AME and AES, our mechanical and electrical consultants, to make sure we actually knew where the devices were going to land, which we don't always do in projects.
Yeah, in addition to that, Amy actually had provided some sections of the bulkhead showing where all their equipment was. All of the consultants designed in Revit World to a LOD of 300, if everybody's aware of that, so that all of the elements were sized appropriately, all the piping pathways and cable trays and conduits were shown up to a certain size. And then the contractor actually used that for their coordination drawings. In our specifications in our Div 1, there's a strict requirement to the contractor, because of all these tight confines, is actually to do coordination drawings and layer on all the other trades to make sure that things were going to fit. This was not a matter of how tall is the trades ladder and that's where the equipment goes. They really actually had to be very intentional with the placement as much as we were intentional with the drawing of the services.
Yeah, excellent. For us, I think that was one of the key pieces of learning that we're certainly passing on as much as we can, that it seems to be a real challenge as we're looking at multi-unit residential buildings. The process is, very indicative at this point. And so, yeah, that is a big shift that the whole group of people who are working on designing and building multi-unit residential are not doing it that way, and so this has turned into one of our key pieces of advice, is that upfront design on that. It seems like it's so small, but you multiply that by however many units will be in the building, it has a huge impact on the space, obviously.
Yeah.
All right. Jay, I see you there on camera. Do you have a question you'd like to ask?
Well, I was going to follow up with exactly what you just stated, is how do you get the trades who are used to doing things, for instance, laying out on the ground as the building is being built, to push that process forward and do their layout during the design? A lot of the folks that we've spoken with, they just can't see that concept.
Well, everybody knows the phrase drink the Kool-Aid. Well, this was a vision by our AOR, by the owners of the building and the entire design team very early on. It was easy to convey the ethos of this project and how important it was, and how important having things intentionally was because of the nature of it. Even right down to the erector, they're a steel trade. They hadn't done mass timber before.
Yeah.
We had kickoff meetings with every major kickoff of every major scope of work. We'd sit down with them, go through that. We as architects would come in and talk about how important it is to be careful with the wood. On the steel erection, they had, you saw the brace, the shear walls, and they were braced on all the columns. We said, well, the ceiling's going to be here in the core. Can you put your braces just above the ceiling so any nail holes and any iron ore runoff are not going to stay in the face of it? They're like, oh yeah, okay, we don't have to put it mid column. We'll put it at the top third. It was just little tweaks like that that everybody understood what it's going to take to do it. The steel fabricator, not the installer, fastened a unique bit on their air hammer to drive the stainless steel pins in that connected all of the brace frames to the vertical structural elements, so that they could set up the brace frames, the prefabricated brace frames, quickly, and then move on and erect this quickly while another crew came around and did all the rest of the pins. So there is innovation at every single level all throughout this, and it did take some additional meetings and work, but once people got it, they got it. And then there was pride and ownership of this all the way through to the end.
I want to add to that. We also, in the beginning, we did a vision statement exercise with the design team, and this really helped set the tone at the very beginning for the project. And we were able to refer back to that kind of through the key design milestones. I think it really helped that we had a fantastic team who brought in some very good experience with mass timber. But then, yeah, setting out the vision for the project from the beginning went a long way.
Yeah, one of the things that we've learned through this process, going through the cost guide, is you want to have an experienced team for a number of reasons, as you've shown here. Plus, also, it helps on the soft cost side with financing and insurance, because the more work you do up front, the more you prove you understand how this is going to go together. The less risk that they feel in backing a project like this.
Yeah.
You know, and then one of the other things that I'm going to point out is you were working on a fairly constrained urban site. So you didn't have much room, it looks like, to sort of store timbers and so forth. Was this all a just-in-time sort of schedule?
Absolutely. Yeah, that was it was a challenge, but again, it was working with the primary subtrade for all the steel and wood. You saw the lot from Klesnikov. They did all the packing and flat packing of it in their yard in Castlegar, shipped it when it was needed in batches to South Burnaby, where George Third and Sons was set up. They have a massive warehouse. At one time, we were taking over almost the entire main hangar that they had. They had QR codes and metal tags on every piece of wood and metal that was for our project, and just laying it all out. They also created a intermittent paint fabrication application booth on their site, which is interesting because it was a different trade doing that, but it was their facility that wanted to do it. So they had a chain of command where it left the main hangar, went out to the paint booth, they handed it off to the paint trade, and then they handed it back in through this chain of command back to George Third, that was putting it all together and connecting those elements to the wood. So on the vertical columns, you would have the vertical column with a routed out pocket underneath it that would accept the plate of the floor below, and then the plates and stub that it was like the through floor or through slab steel connection mounted on top of that. So again, as much of the steel and wood that could be connected in the plant was preferred. And then when they brought it out, there was actually no room on site. They had one curb lane on Great Northern Way, which was, as Lindsay mentioned, a 12-meter grade change, so quite a steep hill. Everybody likes to stall out on that when they're trying to get through the light. And they'd have flatbed trucks. They would jack up the wheels and have big Bertha cranes until they had the permanent crane, as you see in this picture, and just hoist things up. And if a trade was not on point and missed their window, then they had to talk to the GC and come around the next day. And right beside it, I don't know if it was mentioned too, not only is the VCC SkyTrain station there, there's also an active bus lane. So Keith Drive right now is a one-way bus lane right in front of our building. As soon as all the civil work is done in a couple of months, it'll become a two-way lane for the one block in front of our building to allow people into the parkade and into the loading area. So all the vehicle traffic, the construction traffic had to jostle around with a single bus lane as well, going in the opposite direction of into the site.
You really did test out all the constraints possible.
Yeah, we threw everything at it. Yeah. Well, I mean, not only do we have COVID, we had a concrete driver strike, we had a building code change, we had additional traffic to demand management changes, atmospheric rivers, and we had to put sensors all over the SkyTrain just to make sure that any of our excavation that was quite tight in the northeast corner wasn't adversely affecting the piers of this Millennium Line, which is over 20 years old. One funny story is one spring, as we were getting close to bottoming out the excavation, all of a sudden all the sensors on the piers of the SkyTrain started going off, and everybody was, let's say that there was probably some stains in shorts that morning. It just happened that it was after a long, cold, rainy February, and the sun had come out and actually hit all the active metal tabs that were the sensors, and the lasers started reading that as actually the piers moving, but it's just the actual tabs themselves. So they put another nail into those tabs to make sure they didn't rattle around as much when the sun hit them.
I mean, that sounds like the best possible outcome there. Wow. Okay, we have just a few minutes. If anyone else has any questions, again, please feel free to put it in the chat, or if you just turn on your camera or open up your mic and go ahead. I did have one question about, you used the phrase anticipation of costs, specifically with the fire protected stairwell, but in the interest of that idea of anticipating, it seems like this project is all about anticipation. And I wondered, you also used the term integrated design. Did you use an integrated design process? Did you use or just sort of standard, standard meeting processes throughout?
I would say it was standard for how we work today. And this project, one of the city officials said this is by all things is actually an old project now, because it really did start in 2017, 2018. But we use standard, everybody gets on early and does their work early because everything has to be intentional. It wasn't a formal IPD project. It was, a fairly average, BGO was the consultant's contract holder. They manage all the consultants' contracts, but everybody understood that it was going to take a concerted effort early on. And it was a standard CCDC with a number of supplemental conditions from the owner, but it was a fairly standard construction contract as well. And just with the technical documents describing the uniqueness of how to manage with the mass timber. There were clauses in there about using companies such as CAD makers to do the coordination drawings, which we've seen in the past on other mass timber and other projects. UBC uses them a lot. We use them on Vancouver House, but they elected to go with Apex and do their own process. So you saw some of the slides that Lindsay presented. I think there was an understanding that it was going to take a different level of effort, and that was factored in on the construction side. And we didn't see all the financials of all the other consultants, but there was an understanding that was factored into their fees as well during the design phase, was what we understand.
Right. Okay. Well, I see we're at 1:26. I will stop here and ask if anyone has any further questions for the branch team before we wrap up. I see there was a question put in the chat. Lily, if you'd like, or Andrey, to speak to that at all, and if anyone else has any other questions.
Yeah, I put in an answer. I was wondering if you guys saw it.
Oh, yes.
But yes, happy to also share here. The app currently includes a range of CLT, MPP, and DLT mass timber products, as well as glulam that is both European and North American. So from that perspective, we've got a good roster, and we'll be looking to include more suppliers over time. And we do have connection design on the roadmap. Obviously, to dial in that sizing, that last 20% requires some connection design, but we are trying to keep pace with all of the engineering analysis. So we'll dial that in, but looking to kind of release that in the future. We'll keep you guys posted.
All right, excellent. All right, well, it looks like all of our questions are answered from the chat. Again, we will be sharing the contact information for all of our presenters today. So if you have questions, I encourage you to follow up. I would like to thank you all again. This is really incredible. Both teams, both projects you're working on, really supported what we were doing with the costing guide, and I think the lessons that we have learned from all of you, we are certainly going to include them in our advice as we go forward, and refer to both the projects and the systems that you're working on. It is really I don't know how to say this best. It is incredible to see the Hive project in particular, that it has been so long in the development, but the amount that has changed in the industry over the time you've been working on this project, the fact that now there are tools like Branch and TimberX that support people in this design process so they can kind of get in early and quick on the structure, I think is incredible. Also, the fact that you've been so open with how you've developed that project is really helpful, certainly for us, and obviously for everyone that the project's being shared with through Enercan and other methods. So I appreciate your openness with it. It has been really, really helpful. This has been a wonderful presentation. So thank you all again for your time today. And again, we'll follow up with an email with the video and the slide presentations to share with everyone. We're at 1:29. Thank you all for your time, and thanks for joining us, everyone who joined us for the webinar today. We'll be in touch about the next one.
Thank you. Bye.
Thanks, everyone. Have a wonderful day.